Hello everyone, I'm Alfian and today we are going to solve the HackerRank challenge on the data structure section called the delete duplicate value nodes from a sorted linked list. And for this particular challenge, we are given the pointer to the head node of a sorted linked list where the data in the nodes is in ascending order. Delete nodes and return a sorted list with each distinct value in the original list. The given head pointer may be null, indicating that the list is empty. And we have the example of the head, which is refers to the first node in the list. And since the node is in ascending order, so it is starting from 1 or from 0 or anything, from the lowest number and to the highest number possible. We have 1 and the next node, which is 2, 2, 3, 3, 3, and so on and so forth until it hits the end of the node chain. And remove 1 and the 2 data values and return head pointing to the revised list. So for the what it means by removing 1 and 2, it means that we need to remove all of the duplicates of the node chain from this head node and transform into this one that contains only the unique data property of the node chain, which is only 1, 2, and 3 without the another 2 or without the trailing 3 along the way. And then we still returning null because it is marks the end of the node chain. And for the function description, complete the remove duplicates function in the editor below. And remove duplicates has the following parameter. The first parameter, which is the singly linked list node pointer head, a reference to the head of the list. And we only have one parameter called the L list in the form of singly linked list node, and returns the expected data type, which is in the form of singly linked list node class pointer, a reference to the head of the revised list. And for this function, we are using the public static singly linked list node, since this is the expected output of the data type. And the function itself, named remove duplicates, takes one parameter called the L list that we need to operate and return our answer. And for this particular challenge, we are using Java 7. If you want to use something else other than Java 7 language, then go ahead. I encourage you to do so. And the input format, the first line returns an integer t, the number of test cases, and the format for each test case is as follows. The first line contains an integer n, the number of elements in the linked list. Each of the next n lines contain an integer, the data value for each of the elements of the linked list. And we have the constraint of 1, which is the t or number of the test case. It is inclusive to 1 to 10 test cases. And the next line, which is 1, the n values, which is the how many chain from the singly linked list node. We have 1 inclusive until 1000. And the data of every chain of every node, we have the property data inclusive from 1 to 1000 as our data value. Since it is starting from 1, then we can create another node below 1 using the new singly linked list node called the new node. And the new node, we can simply construct our node, new singly linked list node, that takes 0 as the node constructor. Why 0? Is because we have the constraint right here of the third point of the constraint. We have inclusive 1 to 1000 of the data value. Since 1 is included, then of course we need something lower than 1 because it is in a form of ascending order. It is always starting from 1 up to the point to 1000. Since we already create a new node, we need to use this new node as our node constructor as the answer from 1, 2, and 3, and then null as the node answer. To visualize this, we have the new node that we need to iterate, and the node will be filled with the unique data property of every node. So let's say we have the L list that contains the 1, and then the next one 2, then the next one 2, 3, 3, 3, and 3 again, and then null. And for the new node, we declare 0 as the first new node, and then the next one will be 1. Since 0 is not equals to 1, then of course we insert 1, and the next one we compare the new node dot data compare against the next node of the linked list. Since 2 is not equals to 1, then of course we insert 2 into our new node chain. And the next one, we have 2 compare against the current iteration of the new node. Since it is the same, then of course we are not going to return anything and just ignore it. And then we iterate over the next node of the list node chain, which is 3. Since 3 is not equals to 2, then of course we insert 3 as our answer node chain, new node chain. And for the next one, 3 is equals to 3, then of course it will be ignored and move to the next iteration. 3 again, 3 again, and the next one is null. And since it is already null, then of course the next node will be also null. And that is the rough visualization that we need to use. To implement this, we can simply use we already declared the single linked list node called the new node that construct new single linked list node, and we need something to iterate over the new node. And this variable acts as the iterator or the builder from the new node chain, and this one will act to build over the new node, and that creates a chain of 1, 2, and 3 up to the point to the tail of the node chain called the new node iterator that takes the new node variable. Why we create another singly linked list node called the new node iterator? It is because the new node, after we declare the new node right here called the singly linked list node starting from 0, then it points, I'm using the chevron sign, it points to the 0. That is the head of the node that represents all of the node chain after the 0, and then dot next, and then dot next again, and dot next will be null. This is the new node pointer. And for the single linked list node new node iterator, and this new node iterator will act to iterate over the new node that acts as a builder that builds from the node 0 dot next, and we construct new node the data of 1 derived from the list dot data. And then the next one using the dot next property, and we construct new single list node again with the value of 2. And the next one using the dot next property, and we construct new singly linked list node that takes 3 as the parameter, and the next one will be null. That is the usage of the new node iterator. And for this one, we need to don't forget to handle if the list or the parameter right here is already null. Just as an edge case check, if the list is already null, then of course we are not going to return anything by using the return null. If it is not null, then of course we construct new node using the new node iterator again, and we need to somehow iterate over the list node chain by using the singly linked list node called the current or the current node, whatever, and then that takes the list as our variable, and the current acts as the iterator to iterate over the list chain, since list will stays at the head node of 1 that represents all of the chain from the node chain of the list. Then of course we need to iterate over the 2, and then the dot next, we have the current of 2 again, dot next again, and that way will be compares against the new node dot data or the new node iterator dot data to check if it's equal or not. If it is equals, then we skip it. If it is not, then we assign this as the new node constructor of the new node chain. And then to iterate over the list using the while loop while the current is not null, to check if the current is not null, which is not the tail of the list chain, then we need to use the current equals current dot next. This one acts as the iterator, assigning the current variable using the current dot next. That way we move over the, let's say we already the current is pointing to the 1, current dot data is pointing to the data 1 right here of value 1, and then assigning the current equals to the current dot next, and the current dot next will move the current pointer to the next node, which is 2. And since current is not equals to null, since it has the value of 2, then of course we need to iterate over the next node again up to the point to the null. Since the current is already null, then of course the while loop will stops, and this code after the while loop, inside the while loop, will not be triggered because it is already null, or it is already reached the end of the node chain. And above the current equals current.next, we need to compare using the if the current.data is not equals to the current data, which is 1, is not equals to the new node.data or new node iterator.data. So in the new node iterator.data, if it is not equals, since 0 is not equals to 1, then of course we assign 1 as our new node constructor of the new node chain or the list using this new node iterator dot next. Don't forget to use dot next because we are assigning using the next property, and we have to build the new node chain. New node iterator dot next equals to the new singly linked list node. We construct new node, which is 1, and we use the data from the current.data, and we transfer the data from the current variable in the current.data. And then we also need to move the new node iterator, just like the current equals the current.next. You guess it, using the current node new node iterator equals to the new node iterator.next. And that way we are moving after we assign, since it is already a new node, then after we assign the 1 as the new singly linked list node of the current.data, then we move the new node iterator to the new node iterator.next. We move this one to the next property, and the new node iterator acts to build over the new node chain. And after everything has been completed, or the L is already exhausted, then of course we need to return. Instead of returning the new node iterator, we are returning only the new node dot next. Why new node dot next instead of the new node? If we happen to use only the returning the new node, since if you remember correctly, if you still remember it, if we still use the new node, then of course we are returning 0 from our new singly linked node 0, because 0 acts as a dummy node. And that way we are using the new node dot next, and we shift the next value or the next property which points to the 1, and then we return the rest of the 1 after the head of the 1 right here. We are returning 1, 2, 3, and then null. Why only returning new node dot next instead of returning the new node iterator.next? Well, the new node iterator.next, since the if else will checks over the new node iterator.next, and then we assign the new node iterator equals to the new node iterator.next, then the new node iterator.next will points to the end of the new node chain. Let's say we are assigning the new node iterator, and the new node iterator state will points to the end of the new node chain. If we happen to return the new node iterator, either new node iterator or new node iterator.next, then we will point to either only the 3 or the null value instead of the actual data from the actual answer. So we are returning only the new node.next instead of returning the new node iterator. So that is why. Okay, so let's run this out to see if it works. Okay, we have solution error illegal static declaration in another class solution.result. So let's move this out, move this function of the public static function outside of the result class by using the alt and arrow down, and we move this outside of the result class because this is the closing curly brackets of the result class, and this is the public static after the closing curly brackets of the result class. So let's run this to see if it works. Okay, let's submit this. Okay, so that's about it. I hope you understand my explanation. If you still don't understand, you can ask me in the comment section. Or if you have any better solutions regarding this challenge, tell us what you think in the comment section. Thank you for watching the video. I hope you have a great day and I will see you in the next video. Goodbye.